Hi, I'm Olivia from FTC Team Beta 8397, here to demonstrate the installation and use of our 2D FTC robotics simulator called Virtual Robot. Virtual Robot is a tool for students and mentors who are learning Java programming for FTC robotics. It allows you to write OpModes and test them, even when you don't have access to robot hardware. It is intended to be used with the JetBrains IntelliJ IDEA integrated development environment. Before you run Virtual Robot, you need to do several things. First, if you don't have the Java Development Kit 8 installed on your computer, you'll need to install it. To check, go to your list of installed apps. Look for the Java SE Development Kit 8. Note that just having Java 8 isn't enough. You need the development kit. If you don't have it, then bring up your web browser. Search for Oracle JDK and take the link to Java SE Development Kit 8. Scroll to Java SE Development Kit 8U202. Accept the license agreement and download the appropriate installer for your system. Run the installer to install the JDK. Next, you'll need the IntelliJ IDEA Community Edition. If you don't already have it, open a new tab in your browser and search for IntelliJ IDEA Community Edition. Follow the Download IntelliJ IDEA link and download the installer for the Community Edition. Run the installer and accept the defaults. Finally, you'll need to download the Virtual Robot project from our GitHub repository. We've provided a link in the FTC forum and the description of this video. Select the Virtual Robot repository. Download the repository as a zip file. Then, extract the contents of the zip file to a convenient folder or your desktop. Now, run IntelliJ IDEA. Click the Open option to open an existing project. Navigate to the Virtual Robot Master folder. And open the project. Try running the program by clicking the green arrowhead on the toolbar. If you get an error message indicating that no SDK is specified, then you'll need to direct IntelliJ IDEA to the location of your JDK as follows. From the File menu, select Project Structure. Select Project from the panel on the left. Click New and navigate to the location of your JDK. Click Apply, then OK. Now, run the program. You see the two-wheeled robot on the field. It has a color sensor in the center and an arm on the back that operates with a servo. It also has a gyro sensor, motor encoders, and a green mark to indicate the front end. The configuration file is shown in the telemetry area. These are the names that you'll use to access the hardware via the hardware map object in your OpMode. You can switch between two-wheeled robot and four-mechanical wheel robot using the configuration drop-down box. Several example OpModes are provided. OpModes are selected using the OpModes drop-down box. Select the two-wheel bot configuration and the two-wheel demo OpMode. Before running the OpMode, position the bot on the field as follows. Left mouse click to position bot, and right click to change its orientation. Now click Init, then Start. Use the A, X, Y, and B Gamepad buttons to make the bot drive. Drag the left joystick forward and back to operate the servo. Notice that as you drive, data from the gyro, color sensor, and encoders are displayed in the telemetry box. In the project window, within the Team Code module, SRC folder, find the Team Code package. Right-click on it and select New Java Class. Name the class Tank Drive. Immediately after the class name, insert Extends Linear OpMode. As you are typing this, IDEA will provide suggestions. Press Tab to accept the suggestion. IDEA will then automatically insert a statement to import the Linear OpMode class. Notice the red squiggly line beneath the class name. That's because Linear OpMode is an abstract class which declares an abstract method named runOpMode. Any class extending Linear OpMode must either define that method or must itself be declared abstract. We will define the runOpMode method. After all, that is the method that actually controls the robot's behavior. First, let's define two DC motor variables to represent the robot's left and right drive wheels. DC motor left equals null. DC motor right equals null. Left and right are variables of type DC motor, but they are initially null. That is, they aren't yet referring to any DC motor object. Now, we'll define the runOpMode method. Public void runOpMode. So, runOpMode is a method with public access. It can be accessed from any class. Void return type. It does not return a value. No parameters. At this point, runOpMode is an empty mode. It doesn't do anything. The stuff the robot does will be inserted between the curly braces. First, let's put in what will happen during the initialization phase after the init button is pressed, but before the start button is pressed. Left equals hardwaremap.dcmotor.getLeftMotor. Right equals hardwaremap.dcmotor.getRightMotor. Left.setDirection dcmotor.direction.reverse. Now we have created two DC motor objects and assigned them to the variables left and right. We have also specified the left motor is to be run in reverse. Now we will start to issue a statement that causes the OpMode to stop until the user presses the start button. Wait for start. Any code after this statement will start running after the user presses start. We'll put in a control loop here. While OpMode is active, left.setPower negative gamepad 1 dot left stick Y right dot set power negative gamepad 1 dot right stick Y. That's all there is to it. The left drive motor will be controlled by the left joystick and the right motor by the right joystick. Note the minus signs in the calls to set power. They are needed because the gamepad returns negative values when the joysticks are pushed forward. Before trying this OpMode out, it must be registered. This is one place where the 2D simulator differs from the real FTC SDK. In the FTC SDK, you register OpModes by insertion of an autonomous or teleop annotation immediately above the class declaration. For this simulator, do the following. Expand the OpMode list folder and double-click the OpModes Java file to edit it. To the list of OpMode names, add a comma followed by the name of your new class, in quotes, tank drive. Now run the program. Make sure that the two-wheeled bot configuration is selected. Select your new tank drive OpMode. Press init, then start. Now control the robot's movement using the left and right joysticks. You can inspect the code in the example OpModes for more ideas. In particular, the two-wheel demo OpMode demonstrates the use of gyro, encoders, color sensor, and telemetry. If you have problems with the program, post your comments below. Thanks for watching this introductory video.